Today is April 18th, and on this day in the year 1955, one of the most intelligent scientists in human history, Albert Einstein, a theoretical physicist, died at the age of 76, and thus a bright star of physics went out. He introduced a new and bright dimension to understand this great universe. Today's modern physics, be it astrophysics, quantum physics, or particle physics, owes everything to Einstein. About 90% of the contents of Einstein's theory of relativity have been proven correct, and modern scientists are working day and night on the remaining 10%. And it is not far-fetched that in the near future, Einstein will discover the universe's most important objects. The concepts that were theorized to uncover the secrets, especially wormholes and white holes, should also be proved correct and discovered, and man should take a step forward in revealing the hidden secrets of this great universe. After the death of Stephen Hawking, Michio Kaku, the most respected theoretical physicist of today, believes that we are passing through a period of human consciousness development in which we now have a complete theoretical knowledge of time travel and all of human beings. The long-held dream of time travel is now only an engineering problem. Man now has to invent the machine in which he can sit and time travel. He says that the human civilization emerging within the next 1,000 years will be able to travel freely within the solar system in the same way that we travel today in ships that were not possible 100 years ago. All this modernity is the fruit of Einstein's genius and hard work that modern humanity is getting, and should take a step forward in revealing the hidden secrets of this great universe. Isaac Newton, quarantined during the plague in Europe in the mid-17th century, discovered calculus and analytic geometry, and later discovered gravity through the famous apple drop. Humanity remained hungry for answers to these questions, and then exactly 2 centuries later, Albert Einstein was born, who gave a new dimension to the physics of Galileo Galilei and Isaac Newton by presenting the theory of special relativity in 1905, and then the theory of general relativity in the year 1915, at the age of just 26 years, and the human thinking about the universe. The direction of the current was changed. Einstein solved the problem of time and said that time is not the same everywhere in this universe. That is, time is not absolute but relative, and together with space, it forms the 4th dimension called space-time. The main points of Einstein's theory of relativity are: 1. Gravity is actually the curvature of space-time. Space is like a fabric. Just as if a heavy object like a ball is inserted inside a woven fabric, the ball creates a hole in the fabric called warp. In the same way, the Earth also creates a hole, or curvature, within the fabric of space-time. And then within this curvature, the moon rotates in the orbit in such a way that the movement of both synchronizes, and the moon does not fall on the Earth. This is the process of the Earth with the Sun and the Milky Way galaxy of this solar system. That is, everything in the universe is connected with the curvature of space-time of a massive object larger than itself, and this is actually gravity. 2. Space-time is the 4th dimension within the universe and is not absolute. It slows down near a massive object where the gravity is very strong. Einstein called this concept time dilation, which has been proved by various mathematical equations. 3. The relativity of time is related to the speed of light. The faster an object travels on the fabric of space-time, and the closer to the speed of light limit, the slower time will slow down for it. Time would be 0 for someone achieving 100% of the speed of light. 4. The speed of light in space, or vacuum in the universe, is always constant, which is 299779458 meters per second, or 186,000 miles per second. Nothing that has mass can travel faster than that in a vacuum. Light bends when approaching all massive objects, but since the speed of light remains the same, time itself has to dissolve. 5. All massive objects are eventually absorbed by going to a single point or location, which Einstein called a black hole, and said that in the center of black holes, which is called singularity, any mass actually becomes infinite, and time becomes 0. Goes on the other side of every black hole is a white hole, from which you can emerge into another world. Where possible, the laws of nature will differ from our universe. There must be shortcuts to travel great distances within the universe, which Einstein called wormholes. They are a kind of bridges or portals, through which one can cross solar systems or galaxies to reach other hidden secrets within the universe. Until now, among the contents of Einstein's theory, time dilation, the fourth dimension of space-time, and the existence of black holes have been proven and discovered by scientific experiments. Only white holes and wormholes remain to be discovered. Einstein's greatest achievement was that he created an equation for the interaction of matter and energy and showed that matter can be converted into energy or energy into matter. That equation is E(r)mc2. Well, in my opinion, Max Planck's equation of energy quanta HAB is also very important in reaching Einstein's equation for modern physics, because without understanding energy, it is a little difficult to understand energy and the mutual transformation of energy. If Max Planck did not tell us how energy acts in packets in the universe by devising the Planck constant, perhaps modern scientists would not be able to work on it, and today humans would not be able to travel in space. An example to understand this in simple language is that suppose you order tea or coffee in a restaurant. The tea or coffee comes, and when you start adding sugar to it, there is a big box full of sugar in front of you is placed. You pick it up with your hand or a pinch and pour some sugar into the cup and drink tea or coffee. Now, if you are asked how much sugar is in a cup, you will not be able to tell, but if instead of that box, 1 or 2 small sugar cubes of 2 grams are brought to you on a plate, then you will not only know how much sugar you have used, but also through calculations, you will be able to tell how many cubes or how many grams of sugar will be needed for 1 cup, or 2 cups, or 1,000 cups of tea, because you have information about a sugar cube. Now, if you visualize the same sugar cube as energy quanta, then you will get its quantity as constant. Amazingly, within the universe, the Creator has also placed energy in the form of packets called energy quanta by Max Planck. Max Planck not only discovered it, but also calculated it. And so today, science has the Planck's constant of energy, thanks to which you can do every calculation related to energy. If seen, it was also an unexpected blessing for humanity in that era that Einstein and Max Planck passed in the same era. How rare must be the moments when Einstein and Max Planck had regular debates about quantum mechanics. Until his death, Einstein did not understand quantum entanglement, the special process of quantum mechanics, the way Max Planck did. Someday I will report on this topic in detail. Currently, as far as Einstein is concerned, it can be said that Einstein was criticized at that time because the concept of time dissolution and time relativity were not easily digestible for many scientists of that time. And anyway, after Galileo, Newtonian physics was stung, but Einstein came and created a stir. And then the coming era proved that Einstein was right in his position because one by one, the contents of Einstein's theory became reality and were tested on the test of scientific experiments, after have been proven correct. Indeed, Einstein was a physicist whose achievements cannot be covered in a single text. Many books will be required for this, but as a student of physics, I have tried to understand these things in a common-sense way. Like me, my aim is to remember the eternal scientific services of this great scientist to pay tribute to him on his death day. In the eyes of a physicist, if I have written something wrong or misquoted in this video, it should be ignored. Thank you! Don't forget to like, share, and subscribe for more captivating content.